Welcome to section 6.3, where we're going to start looking at exponential functions. So now you will now notice that x is no longer in the base position, it's in the exponent position. So our exponential function will be f of x, or y equals b to the x. And the first thing we're going to do is we're going to put some restrictions on this base value. First, we don't want any base to be negative or 0. 0, I think, is quite obvious. 0 to any power is always 0. So we just get a horizontal line. Next, we don't want negatives, because if you have a negative base, let's say you had negative 2. Well, negative 2, if x was 0, that'd be negative 2 to the 0 power. Then negative 2 to the first power, well, that'd be down here at negative 2. Then negative 2, all that squared would be a positive 4. Then power of 3 would be negative, power of 4 would be positive, and our graph would be bouncing back and forth all over the place. So we don't want that. So no negatives, no zeros, only positive numbers for your base, with the exception of 1. We don't want the base to be 1 for the same reason we didn't want the base to be 0. 1 to any power would always be 1, and that would be a horizontal line. We already had those constant functions. So if we look at an example here with our base being 3, you put negative 1 into x, and then you're going to use your negative exponent rule, which means take the base 3, it's in the numerator, put it in the denominator, and call it 1 over 3. And we'll plot that point, negative 1, 1/3. 3 to the 0, well, any base that meets these criteria raised to the power of 0 will always be a 1. So there's going to be 0, 1. 3 to the first power will be 3. And 3 squared will be 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our graph. So this kind of looks like the right-hand side of a parabola that we were working with before. But if you go back over here and you look further to the left, if you took negative 2, well, that'd be 1 over 3 squared, or 1/9. Negative 3 would be 1 over 3 to the third, which is 1/27. 1 over 3 to the fourth, which would be 1 over 81. So we don't get the left-hand side going back up. In fact, it's going to flatten out right here. So the one thing I want you to notice is we also have another terminology here called the common ratio. And the common ratio is this value in your y's. 1/3 times 3 is 1, 1 times 3 is 3, 3 times 3 is 9. This 3, which is your base, is also recognized as the common ratio. So sometimes they'll use the variable r for the base, sometimes they'll use the variable b. They're interchangeable. So as I was mentioning about our x's going off to, if you will, negative infinity, we're actually approaching a horizontal asymptote line right here. So now my graph is starting to create characteristics. So 5 characteristics of a basic exponential function. Please asterisk this. This will be on the test. I will ask you this question. You will have to memorize this. Number 1, well, those are your base restrictions. You gotta have those. Number 2, we noticed we had a horizontal asymptote at y equals 0. Number 3, I went to my graphing calculator and tried some different bases, 2, 4, and 10, all to the x power, and I made the graph. And I noticed they all cross the y-axis at the same place, which is that 0, 1. And again, it doesn't matter what your base is, raised to the 0 power, whether it's 2, 3, 4, or 10, all raised to the 0 power will be a 1. So we're going to have what is known as a common point at 0, 1. Number 4, well, when you talk about functions, you have to talk about domain and range. So the domain of our function will be all real numbers, negative infinity to positive infinity, but the range, your y-coordinates, they're restricted. This graph will never cross the y-axis. Therefore, your range of your basic exponential function, you will always generate positive y's. And for number 5, doesn't jump out at you right away, because the one thing we haven't looked at is, what about bases between 0 and 1? What about those fractions? So I change this to 1/2 to the x, 1/4 to the x, 1/10 to the x, and looked at the graph and notice instead of going uphill, being increasing, they're all going downhill. They're decreasing. So that's number 5. If your base is greater than 1, your functions will always increase. If your base is somewhere between 0 and 1, you will always decrease. Next, we need to talk about our transformations of our graphs. So just like we talked about those transformation rules back in chapter 3, we're going to have them here for this exponential function. So notice now I removed the b and replaced it with r because we used b before in our transformation rule. So I wanted to stay consistent with that. All right, so make sure you understand that. So now this is my base r. B is in the position for my transformation rule. So a, if it's a negative, it flips over the x-axis. And if the absolute value of a is between 0 and 1, it's a vertical shrink. And if the absolute value of a is greater than 1, it's a vertical stretch. The exact same rule as what we had before. So here, a, because it's on the outside of the function, you will always multiply this to the y-coordinate. So if we just take a quick step back, all these y-coordinates, like on the common point, if I'm not at 0, 1, let's say I'm at 0, 5, 1, 2, 3, 4, 5, my point is right here, and my graph is still coming down to this horizontal asymptote, then I know that my a value is 5 because I multiplied 5 to that 1 to have that point at 0, 5. And all these other y-coordinates would be multiplied by the same a value. B, remember B is just the opposite of whatever A is. Vocabulary, everything. If B is negative, it flips over the y-axis. If our absolute value of B is between 0 and 1, instead of vertical, it's horizontal. Instead of shrink, it's stretch. Remember, they might use the word compression for shrink as well. And if the absolute value of B, and that looks weird. What happened to my absolute value bar there? All right, so if our B is greater than 1, it's a horizontal shrink. You're shifting left or right. Remember, we said whatever in the exponent position, set that equal to 0, solve it for x, and that will be the true horizontal shift left or right. If x equals a negative, you go left. If x equals positive, you go right. And D is on the outside of the function, so that's face value changing your y's. That's your vertical shift going up or down. All right, so let's look at some graphs. Let's say we're going to translate 3 to the x. So what I want to do is go back in my graph here, when I made my table. Here are going to be 3 good starting points. Common point right in the middle, and -1, comma, will always be 1 over the base. And when you have a +1, you'll have 1 comma the base. Now, if your base happens to be small like 2, you might be able to put in comma 2 comma the base squared, because then you can do 2 squared, which is 4, which is going to fit. 3 squared here might not fit on our graph, but these are 3 good points to start with. And like I said, you can always plug in, if you want to write in the second, then a 4th point, 2 comma the base squared. So these are my 3 starting points. -1, 1 over 3, my base, 0, 1, and 1 comma my base 3. I have my horizontal asymptote at y equals 0. Okay, here's negative. That's not on my base. That's technically -1 being multiplied to my base 3 to the x power. So a is 1. As we said, if a was negative, you're going to flip it over the x-axis, and that's going to be my graph. So 1, 3 is now at 1, -3. 0, 1, 0, -1, -1, 1/3, -1, -1/3. Here, notice that now my base 3 is raised to the x minus 2. So now something is inside my function. This is going to change my x's. So again, starting with your 3 basic points before, these will all be base 3 graphs. So if you want to pause the video and plot those 3 points on all the graphs in your notes, go ahead and do that because we'll come back to it. You don't have to draw the curve because we're always just going to move those points. So the x minus 2, I set that equal to 0, solve it for x equals a positive 2. That tells me all 3 points are going to shift to the right 2. So I move them to the right 2 and draw in my graph. In our next example, now we have 3 to the x, but now the -5 is not in the exponent position. It's at the base level. So this is my d value. So all 3 of my points are going to shift down. But before you do that, move the horizontal asymptote first, down 5. So this gives you a good idea. This is the boundary. Nobody can go past that horizontal asymptote. So I start counting down 5, 1, 2, 3, 4, 5, plot a point. 1, 2, 3, 4, 5, plot a point. 1, 2, 3, 4, 5, plot a point, drawing your curve. And we can have 2 or more transformations going on. Here we have x plus 2 in the exponent position. Here we have the -1. So we're going to be shifting left or right, then up or down, based again on our signs. So x plus 2 set equal to 0 means x equals a -2. So all my points are technically going to go 2 to the right first. And what I like to do here, I'm just going to plot open circles once I shift them 2 to the right. Then from here, everybody goes down 1. But again, take your horizontal asymptote, shift it down 1 first, then move all your points down. All those open circles just move down 1 unit, and I draw in my graph. Now here, now there's a value being multiplied to my 3 to the x. So here's my a value of 2. So that 2 means that all my y coordinates of my beginning points are all going to get multiplied by 2. So at this point here, I'm at 1, 3. Take the 3 and multiply it by 2. I'm going to be at 1, 6. My common point is at 0, 1. Take the 1 multiplied by 2. I'm at 0, 2. Here my y coordinate is 1/3. -1, 1/3. Multiply that by 2 puts me at 2/3. And then draw in your graph. So here we're graphing -2 now being multiplied to 3x plus 4. So again, with the plus 4, that's going to automatically shift up that y equals 0 to y equals 4. That's probably the first thing I want to put in, because that's going to be my boundary line. Next, I'm going to take -2 and multiply it to every y coordinate. So there's that 1, 3. 3 times 2 is now -2. 0, 1. 1 times -2 puts me at 0, -2. -1 and 1/3. That 1/3 multiplied by -2 is now at -2/3. Now I'll take all 3 open circles and move them up 4 squares. So everybody goes up 4 squares. And I draw my curve. So I have to stay below the horizontal asymptote, is because that negative, if you remember, like we did on the first graph, that was technically -1. That flipped us over the x-axis first, and then multiply by 2 If you wanted to flip those points and then multiply those by 2, you'd still come to those 3 open circles. All right, so that's the end of part 1.